Okay, this should wrap up our Chapter 3. We should be, we'll finish up selection statements, look at some alternative ways of doing selection. We will skip section 3.16. It doesn't add a whole lot to understanding the use of selection. So you'll get an idea of where we're going. We'll discuss the use of Boolean or logic operators. We'll use these to construct selection statements such as if gender equal male and age greater than or equal 21, let's do something. We'll explore these Boolean operators using a leap year calculation, a program to determine whether a given year is leap year or not. Then we'll look at an alternative to if statements, and that's the switch statement. And it's really a programmer convenience. Imagine having to write a program that counts the students in each state. With our if statements as studied up to this point, we'd need to write at least 50 of them. Switch allows us to do this more simply, as well as probably make our code a little bit more readable. And then finally we'll end our discussion talking about how to format our output more pretty print, as I might call it, and then look at a little bit at all the operator precedence and associativity now that we'll have finished the selection statements. Well, we'll discuss each of these operators in more detail in the next few slides, but for the most part, they're used to combine Boolean expressions in order to test more interesting requirements. That example, if gender equal male and age greater than or equal to 21, we need to join those two statements together, and since it's an and, we would join it with the double ampersand sign. Well, we use truth tables to help us understand how these Boolean operators work. The left side of the table under the column headed T represents a proposition, such as assume age equal 21 or 24. And then the right side represents the result once the Boolean expression is evaluated based on the operator. So the first operator we're looking at here is the not operator. And it's a very simple operator in that it simply changes what would be either a true or false result to the opposite. So it's kind of like the negative sign when we want to change the sign in arithmetic. Right? So when we are looking at our Boolean expressions, we need to remember that as in arithmetic, we always evaluate an expression in the parentheses first. Right? So in this example, if we look at and assume that age is 24, and we test for age greater than 24 inside the parenthesis, that would be true. And then we apply the not operator, so the result is false. Take a look at gender. Right? Now this has two nots applied to it. Right? It has gender not equal male. Well, that's false. We know from our assumption above that gender is male. Right? So gender not equal male is false, and then we apply the not operator, we get true. Okay? Well, now we get a little bit more interesting, because if we start using the Boolean or logic operators such as and, we're trying to match up two propositions, right? And with two propositions, each proposition has the opportunity to be either true or false. And so if we have two of them, then we have a combination of four possibilities. So the left side of the table shows all of the possibilities, right? Possibility 1 is proposition 1 is false and proposition 2 is false, and so on. With the AND operator, the only time we have a true outcome is when both propositions are true. So if we look at our assumptions, propositions, and then we test that age greater than 18, well, that's true, and gender equals false, that is true. So under the rule that both have to be true, our statement is true. If we look at the second example, age greater than 18 and gender not equal female, that's false, because the second Boolean expression is false, right? So in that case, only one of the propositions, one side of the AND was equal. Right? Should note that in Java and in many languages that the language will short-circuit the comparison if it can immediately determine the outcome. So for example, if we look at line 1 or 2 on the left side of our truth table there, if proposition 1 is false, the Java will immediately return false. It won't go on to test proposition 2 because it knows it doesn't have to. It short circuits. It says, I know that I'm dealing with an and in this case, both have to be true, so if the first one's false, I don't need to check the second one. That's called short circuiting. Well, the OR operator, which are the two bars, normally that's the key simply above the return key on your keyboard. You need to hit that twice. But just kind of the opposite. The only time an OR condition is false is when both propositions are false. So in this case, we will return a true when either one or the other is true or they're both true. So it's important to understand the AND and the OR and how they work together. The exclusive OR, denoted by the caret above the when you do Shift 6, right? That's kind of a special OR condition. It tests for whether either proposition 1 or proposition 2 is true, but not both, right? So we've taken out that OR condition when both proposition 1 and proposition 2 are true, and have made that a false statement. So we want only one or the other. You could test if gender equals male, exclusive OR, gender equal female. Can't be both, right? So we would use an exclusive OR for that, right? So it doesn't change the outcome if they're both false. It still will be false. Right? So it's a special case of the OR statement. Okay, here's some interesting code examples of using Boolean expressions. Note that the Boolean expressions are contained within parentheses, and in this particular example, the two Boolean expressions that we are testing are also contained within a set of parentheses, so we have some balanced parentheses here. Also, it points out that, you know, if we just want to print whether this number is divisible by 2 and 3, or we just want the outcome, Boolean expressions evaluate to a value. And so these expressions will either evaluate to true or to false. And when on my display, we'll show those values. If we look at case 1, and we assume that the number entered is 4, the 4 is divisible by 2, so that's true, but 4 is not divisible by 3, so that's false, and then I have a true and a false, and so the result will be false. And then it'll print, is 4 divisible by 2 and 3? False. If the number is 6, both those expressions in case 1 will be true, and we will print true. Looking at case 2 using the same numbers. Right? In either case where I enter a 4, right, it'll print true because it's an OR condition and only one has to be true. If I enter a 6, and even though both are true, it'll enter true. And finally, in case 3, where I have the exclusive OR, right? Again, if I enter 4, the first Boolean expression is true, the second Boolean expression is false, and for an exclusive OR, that's what we want. We'll display true. If I enter 6, this is a case where both expressions are true, and consequently with an exclusive OR, it's either one or the other, but not both, so it should display false. All right? You should probably maybe try a little bit of this code in either NetBeans or TextPad just to convince yourself how those things work. Well, the leap year program demonstrates the use of these Boolean operators. It's available on Blackboard. Just kind of want to take a look at the pseudocode so you understand how to determine if a year is leap year or not. So we all know that if the year is divisible by 4, we know that is a leap year. But it's not if the year is also divisible by 100. So if we look at the year 1900, we know readily that that's divisible by 4, but it's also divisible by 100, and consequently the year 1900 was not a leap year. Okay? But if the year is divisible by 400, right, such as the year 2000, then it is a leap year. So we have every 400 years, the beginning of the century is a leap year, right? So the pseudocode is pretty straightforward. Stop the video if you want and study it a little bit, and then we'll look at the code that implements our pseudocode. Okay, here's a snippet of code from the leap year program on page 90 and 91 in your text. The program is also available on Blackboard. And we're really kind of interested in line 12. I've highlighted the two different Boolean expressions. The first Boolean expression in the yellow is testing for that condition that the year is divisible by 4, but the year is not divisible by 100. So remember, to determine if a year is, any number is divisible by another number, we can simply use the remainder operator. Okay. Then we have the Boolean expression in the blue, which tests for our second condition, and that is the year is divisible by 400. And then joining those two propositions, those two expressions, is the OR operator. So the parentheses are evaluated first, and then the OR operator. Later in the lesson, we'll discuss order of operations in a little bit more detail. Okay, this example is kind of interesting. We're going to create a little lottery program. The program will pick a 2-digit random number, and if the user matches that number exactly, they'll win $10,000. If the user doesn't match it exactly, but he has the 2 digits correct, so in the example, if the number picked was 45 and they guessed 54, so they've just reversed the digits, we'll give them $3,000. And if they have any one of the numbers correct, so again, if we pick 45 and they pick 35, then they have one of the digits correct, and we'll award them $1,000 for that. All right. So we'll take a look at some of the code. All right. We'll look at some pseudocode and then some of the code. Well, the pseudocode points out in step 1 and 2 that I have to first get a 2-digit number, either randomly or in step 2 from the user, and then in both cases I have to record the digits of that number. So not only do I need to know the number, I need to know the digits of the number. And then it's simply if statements to test if the numbers are equal, if the digits match, or if one of the digits match. So the pseudocode is pretty straightforward, but you say, yeah, that's easy for you to say. Let's see how we implement it. Well, let's discuss just the first 2 steps in our pseudocode. Step 1, we need to generate a random number, and we can use math.random. And remember, that generates a number between 0 and 1 as a decimal. And if I multiply that number by 100, right, that's going to shift the decimal places to the right. And then if I cast it as an integer, it's going to truncate the decimal portion. So in this case, the example in the pseudocode shows that I have number 67, for example. Then to get the digits, right, as long as I have a 2-digit integer, 67, if I divide by 10, that'll give me the leftmost digit. So that's the first digit. And then if I take the remainder of dividing by 10, that gives me the rightmost digit. So the comments there point out what the results of those operations are. And then as far as the user's number then is concerned, it's very straightforward set of code again. Just kind of repeat the process of how we handled the random number. All right? So once that is done, all that is left to do is to determine if our user is a winner. Well, if you remember from our pseudocode, we have to test for 3 conditions. The number is exactly equal, the 2 digits of the number match, but the number is not exactly equal, or any one of the digits match. I've labeled the code 1, 2, and 3, and 4. So the 1, 2, and 3 are the 3 conditions we test. And if none of those are met, then test 4 is not even a test. It just says, oops, you haven't made a match. So we test number 1, and we look up there, are the numbers exactly equal? Right? And since this is, if they are, since all of the rest of the tests are conditioned with else, we would say that the user wins $10,000. Now, if that's not true, if it's false, then we would go to step 2, the else if. Because remember, the else is the false side of the if above it. And now we're looking to see, all right, are the 2 digits are the digits matched somehow. Now, I only have to test for digit 2 equal digit 1 and digit 1 equal digit 2, because if I had a test if digit 1 equals digit 1 and digit 2 equal digit 2, then that would be the same as testing if the numbers are exactly equal. So I only have to match the other two digits. Right? If that is false, all right, now we have the else that matches up with that if. So remember, when we do else's, we start from the bottom and match them up to the first if that we find that's not paired up. Right? And finally, in test 3, it's just checking to see if any one of the digits is equal. Right? And so that's an OR condition. See, number 2 was an AND condition. We had to match both digits. Number 3 is an OR. Any one of the digits match. And finally, if none of the digits match, then we hit the else for that condition, and oops, sorry, there's no matches. Okay? The next slide is going to rewrite this logic, and I want you to convince yourself if the rewrite will produce the same results. You might want to pause the slide here a little bit and study this slide before you move on to the next one. All right, stop the video here now and do a walkthrough and see if the results have produced the same thing. Well, if you walk through a couple examples, you might have figured out that the logic in the previous slide was only correct if somebody was a loser. If I was the big winner, then it would have told me that I won $10,000, $3,000, and $1,000. So it told me I'd win all three jackpots. Point is that you need to understand when to use the else, that you want to exclude once you've other tests once you've found a test that is a true condition. Well, the switch statement can replace the need for many if statements. As I mentioned earlier, it's really a programmer convenience type statement. It doesn't do anything more than what I can accomplish writing several if statements. And in fact, it has some restrictions on it so that I would have to use if statements. Notice how the switch statement is constructed. Starts with the keyword switch, and then in parenthesis, this is the variable that we are testing. Right? And then we have the code block braces that opens then the set of case statements that will be tested. Right? A break statement terminates the switch. Right? So it terminates the code that would be executed if any one of the case statements is true. Right? So let's take a look at the next slide and understand some of the restrictions and how the case statement works. Well, the variable to be tested, called the switch expression, really isn't an expression. It is can be a variable. Right? That's in the parenthesis. Then, following the opening brace for the code block, we have several cases that we want to test. And the case statements test to see if the expression in the parenthesis is equal to the value specified after case. And notice that the value is followed by a colon, not a semicolon. Right? Once the value is tested and it's true, then we can have a series of statements that follows the case, that what we want to do, and then that is followed by a break. The switch expression is limited to values that are character, byte, short, integer. All right. So we can't test everything. We can't test doubles and things like that. All right. And then our values must be the same type as the expression in the switch expression there. Right. Our values can be literals, so I can be testing age for 21, or it can be a constant of this, but they have to be the same type. If we have no matches for the case statements that are shown, then we have a case of doing a default, right? When the default code would be executed. Well, this slide notes that the break statement is optional, but it absolutely should be used at the end of each case in order to terminate the remainder of the switch statement. If the break statement is not present, then the next case statement will be executed, and so on. Again, the default case is optional. It's kind of like the if then else, all right? So it'd be the final else. If none of the conditions above are true, then do this. Right? Case statements are tested in the order that they appear. Doesn't mean that the values have to be in any particular order. All right? So just kind of depends on your programming logic, whether you test for values, the most frequently occurring values first, and then other values later, right? Good programming style says follow a logical sequence, right? And place a default statement at the end. It doesn't have to be at the end, but that's where you want it, right? Because if it was in the middle, any case statements that would come after the default statement would not even be tested, right? So the next few slides demonstrate the proper use of the break statement. We'll go through those pretty quickly. All right, we start with the character variable ch, and we'll assume that ch is equal to a. Now the idea of the switch statement is to print out the character that matches ch. So the case statement is going to compare ch equal to a, ch equal to b, or ch equal to c, and then print out the proper character. So notice that in this example we have written our switch statement without break. So once we start our case statement, the first test is for ch equal to a, and we know that is true because we've assumed that ch is a. So since ch is a, the statements following the case statement would be executed. In this case we only have one, but we could have many statements, and so the output is a. Now here's where the rub comes in. Notice that it's also executed the line that says B. And lastly, it prints out that we have a C. Well, that's bizarre. CH is equal to A, and our intent was that it should only print A. So what's going on? Well, the final thing here is that after all the switch statements, program execution would continue at the statements outside of the code block. Our bizarre behavior was caused by not terminating each of our case statements with a break. So that is an example when we have not used break. We'll now continue and show what happens when we do use a break. Okay, we have the same scenario. CH is still an A, but notice we've added a break to each of our case code blocks. It's not necessary that the code blocks be enclosed in braces here. You could, and it wouldn't change anything, right? And our last case, the case of CH equal to C, we don't have a break there. Well, it doesn't require one because that's the last case in our scenario here, and it would simply, once it did what it was told to do, fall through to the next statement in the program. So CH is A again. Yep, let's do the test. Is it an A? Since it is an A and it's true, it's going to execute the print line statement. So we output an A. And now we'll execute the break statement. So we'll really bypass the rest of the statements in the switch statement. We're done. Since we're done, program execution then will continue at the statements following the closing of the code block or switch. Each case or default condition kind of delimits the code for the conditions. Consequently, that's why braces aren't needed. But you can go ahead and use them if it makes your code more understandable. Well, we've pretty much covered the selection statements, the if-else, nested if, and the switch statement. So switching gears there a little bit, let's talk about the printf method. It's part of the system.out class, and it's an especially important method in that we can use it to format our output. If we look at the syntax in parentheses, it talks about a format item and items. So it takes two arguments. Well, format is the string that we want to print. It can contain any message along with format specifiers within that message. So format would always be enclosed in double quotes. Now, the format specifiers that are placeholders in our output string, they specify how each of the items following the format string, how they should be displayed. And specifiers always begin with the % sign. So our formatted string then is followed by a list of items, each of which needs to match up with a particular specifier in the string. The items are matched to the specifiers in the order that they appear. And an item can be numeric, it can be character, it can be Boolean, it can be any of the values that we have come to know. So this slide shows the specifiers that are frequently used, the ones that we probably would use most commonly. Notice that they begin with a % sign, and then they have a character that identifies what type of value is going to match up with this specifier. So a %d is a decimal integer, and a %f is a float. And we can use %f for doubles as well. So if we look at the code that follows our specifier, our chart here, we see that we have system.out.printf, and then we have the format, which is enclosed in quotes, And as we read this, we say we're going to print count is %d, so we're going to print a decimal integer. And then we're going to print the words and amount is %f, and so we're going to print a float or a decimal amount. And then we look at the items that we are printing, count and amount. So the items that we're going to print must match the specifiers by data type and in order. Right? So they must be the exact type. Right? If your specifier is %f or %e, then what you are going to, your item B must be a float or a double. For example, we can use %f with 40.0, but we can't use it with 40 because 40 is an integer, and so it will not coerce the integer to be a float. So there's no implicit casting. Right? Notice the specifiers are just part of the string. That whole string that we want to print is enclosed in quotes. So in addition to identifying the data type and where we want to print it in our string, the specifiers allow us to control the size of the output as well as the number of decimal places that we might want to display. So we can back away from rounding that we have learned before, or how we've learned to use the int and convert something to 2 decimals. So if we look at the one example in the middle of the slide here, %10.2f specifies that we're going to be printing a floating point number. It will take a total of 10 positions on the screen, 7 digits to the left of the decimal point, the decimal point, and two digits decimals to the right. So if we have 7 plus 1 is 8, plus 2 is 10. So the size 10 takes into account the decimal place as well. Any unused digits to the left of the digits, right, are filled with spaces, and any unused digits to the right of the decimal point would be filled with zeros. And a nice thing that the printf can also do for us, it can also round automatically, so we don't have to be concerned with the rounding unless we want to round the values before we do arithmetic with them. Okay, our code that we developed last week or the week before, where we took a double and multiplied it by 100 and then converted that number to an integer and divided that by 100 to get our number down to 2 decimal places, that could be replaced with the printf method. It can't be replaced if we need the 2 decimal places in terms of using only 2 decimal places in our computations. But for display purposes, the printf will do everything we need to do in terms of how we display our numbers. So if we look at the example, okay, the specifier is %4.2, and it's so the format string is x is whatever I'm going to replace that specifier with, and I'm going to replace it with x. Now we know that 2 divided by 3 is a repeating decimal, 0.6666666. When we use the printf command, notice that the output is 0.67. So the printf command automatically rounds our numbers for us on output. One other thing is, by default, our output is right justified. So that means if I reserve 10 places to print a value, the value will be right justified in that 10 spaces. We can change that and make our output left justified by using a minus sign along with the specifier. Right? The percent is always first, so we don't put the minus sign in front of the percent, but the minus sign would come after the percent, then our size, and then our specifier. So that would give us a left justified. So take a look at the two statements there. Note that the second set of examples, they have no messages, so they're just specifiers, but they're still enclosed in quotes. It's a string. The string terminates with the escape character for a new line. And so our items to be printed is the literal 1, 2, 3, followed by the word Java, followed by the 5.6 decimal. So pause the video for a minute and work out what you think the output for this example will be. So here's the output of the two statements. Notice the even though 1, 2, 3, 4 was a 4-digit number, I reserved 8 places, and it space filled to the left of that in example 1, and right filled to the right of that in example 2. So I hope you got a little better understanding of how we can use printf and make our output a little bit more meaningful to our users. Okay, we're coming to the end of the session. In the last 2-3 weeks, we've learned a great deal about arithmetic, and now about selection and the if statements. We have all types of operators, and just as you are familiar with the order of operations or the order of precedence in arithmetic from algebra, with all of these operations now, all these special operators for postfix and prefix and casting and the not operator and all of our comparison operators, we need to have some type of order of precedence. So what we see is that some of those special type of operations come first, followed by arithmetic, followed by the Boolean operators, the greater than, less than, equal. And notice that the greater thans and less thans are come before equality. So comparison comes before equality. And then we are followed by the logical operators, the exclusive or, and the regular or, the conditional or. Notice that and is evaluated before ors, right? And then we have those special assignment operators that are last in our order of operations. Okay. We can use parentheses, and parentheses will change our order of operation in that whatever's inside parentheses is evaluated first, and if we have parentheses inside of parentheses, the same rule applies. The inside parentheses are evaluated first, and then the outer parentheses. In the absence of parentheses, we need to look at the order of precedence. Basically, if it's on the same order, such as the multiplication, division, and remainder, those are all the same order, There's no precedence given to any one particularly. If those were in an expression without parentheses, they would be evaluated left to right. So everything basically is left to right without any parentheses, with the exception of the assignment operators. Those are right to left. Okay. So it'd be really very odd where we might be using all these different operators in one statement. All right. Basically, we can have a mix of arithmetic and Boolean, and so I made up a little mnemonic for you to remember. A breakfast comes before lunch. So the arithmetic operators, come before the Boolean operators. That's the less than, greater than. It comes before the logical operators, the and the ors. Right? As far as a mnemonic to remember how the ands and the ors go together, just think of your ear. The exclusive or, E, then the ands, A, and then the R for ors. So hopefully those little mnemonics will help you kind of remember the order of precedence here. This order of precedence chart is on page 98 in your text, and I might recommend that you dog-ear that page or put a paper clip on that page just to use it for reference purposes later on. Well, this looks like a really ugly example. However, pretty simple in that we just have arithmetic and Boolean logic operators in there. So remember, a breakfast comes before lunch. Arithmetic comes before breakfast, Booleans, and then logic, and we don't have any logic here. So the first thing, of course, to evaluate is the parentheses. All right, so we evaluate that. Notice that becomes 7 in step 2. And then we're going to do the multiplication from left to right. So we're going to do 4 times 4, followed by 5 times 7. And then we're going to do the addition and subtraction left to right. And we're finally left with the Boolean expression is 19 greater than 34. So this would all equate to false. Interesting.
Huh?
Well, that's it for Chapter 3 and selections. We've got one more programming structure to talk about, and we'll do that in Chapter 4. I sure hope you don't feel like our little clip art person here.